Hey guys, we are back. We are looking at a new combination of some trigonometry stuff. I mean, if you remember, the course is called Algebra 2 Trig. Okay, trig stands for trigonometry, which for a lot of you, sine, cosine, tangent, you kind of remember a little bit of that from geometry. Okay, that's trigonometry. That's part of trigonometry. Obviously, all you guys that are going to go on to pre-calc next year, we'll do a lot with trig. I mean, pre-calc is probably half of it is trig. So we go a lot deeper in all this stuff in pre-calc. In Algebra 2, we're kind of just hitting some basics. Okay, now here's a big word, radians, which you've probably never heard. Now, most of us have, obviously, we know the word degrees. Okay, so when we say, something is a certain amount of degrees, we know that we're talking about the angle, right? I mean, when you were doing geometry, so if I had the center here, okay, and then I could say this angle right here is 60 degrees, okay? So that angle, the distance of that angle is 60 because we also know, all the way around is 360, halfway is 180. I mean, we know angles by degrees, 60 degrees, okay? But guys, here's the problem that really in engineering, in the application of circles, what you care more about is the actual distance that it's covered. So right here, what I'm actually saying is how much distance out here was covered in that circle, because if you think about it, a lot of machinery, I mean, if you look inside the hood of your car, there's a lot of circular things. I mean, even if you look in, like, I guess digital watches don't, but old watches that actually run, everything's a gears. You've heard of the word gears. They're rounded and they kind of, the teeth of them fit together. So most things in engineering are circular. Okay, but the angle doesn't really help you when you're engineering. The distance that circle covers is actually what's important in engineering and in math. And if you remember, around a circle, you'll remember this is circumference, right? Remember circumference from geometry, okay, which is all the way around, okay? And if you remember, circumference is 2 pi r. Remember that? 2 pi r, okay? Now, obviously, r is the radius, okay? Like how far this is, that's the radius. But guys, the radius goes with the distance around the circle. And guys, really, 2 pi represents the distance around the circle. And it's not obviously degrees. It doesn't say 360 r, it's 2 pi. So now again, I'm not going to be able to get into all the details of this, but whenever we're talking about the distance around a circle, like we're saying, instead of 60 degrees, we're actually going to use pi, 2 pi. So all the way around a circle is 2 pi. And the units using pi, the units using 2 pi is radians instead of degrees, which is 360. Radians is that 2 pi distance. Okay, that's just all to try to help you understand a little bit. But what we have to do then, and we're going to apply this later, is I want to change these degrees to radians or units of pi. Okay, now I know that sounds weird and doesn't seem to make sense. Okay, but what we're going to do is change the units, and I can change any units of degrees to radians. And then we can use that to actually find that distance, that circumference distance on any circular item, okay? So anyway, the units that we do, if I'm going to convert degrees to radians, you always multiply by pi over 180, Okay, so guys, that is the conversion right there. You multiply by pi over 180. What does that mean? I'm going to take, now 270 I need to make into a fraction. Remember, guys, any number can be put into a fraction over 1. So I'm going to put 270 over 1. Excuse me. And then again, just like I was showing up here, pi over 180 is the conversion formula. Okay, that's how you convert. So I'm going to multiply 270 over 1 times pi over 180. Okay, obviously that looks weird, but guys, really, we just have a fraction times a fraction. Fraction times a fraction. Now, if remember, I can cancel diagonally. I can cancel whatever's here with whatever's here. Now, again, you'll definitely want to have your calculator, but guys, here's a shortcut, and we're going to do this for this first video on this. If there's a 0 here and there's a 0 there, I can cross out 1 on each. So if this was 200, I couldn't cross off both zeros, but I can cross off 1 0 here as long as I cross off 1 0 on the 180. Now, what's nice, guys, this is always 180. So this is what we're going to use every time, pi over 180. So you're always going to have a 0 on 180. So if your other number has a 0, those zeros can cross each other out. So now what I have now is 27 and 18. Now, guys, pi is never going to go away. I mean, look, there's nothing else to cancel pi with. And we know that that's 3.14, which we know back from geometry and stuff. And we're going to use that in later videos. But now what I have is 27 and 18. Now, guys, again, I can cross diagonal cancel by the biggest number that goes into 27 and 18. Now, again, for some of you, this is going to be easier. Some are going to be a little challenging. What's the biggest number that divides into 27 and into 18? That's what I'm trying to do. What divides into 27 and 18? Now, again, for some of you, this is not too hard, but I could divide by 9. 27 divided by 9, because 18 is also able to be divided by 9. Now, 27, 18 could be divided by 3, but then if I divide by 3, I would have to actually divide by another 3. So, guys, you want to divide by the biggest thing possible. So 27 divided by 9 is 3. Okay? Now, pi is still there. Now, 18 divided by 9. 18 divided by 9 is 2. And then basically, guys, there's nothing else can cancel. 3 cannot cancel with 2. Pi obviously can't cancel with anything. So we just, remember, multiplying fractions, you just multiply across the top, across the bottom. So 3 pi, 1 times 2 is 2. Boom. Guys, that is the answer. 3 pi over 2 is the radian measure that's equal to 270. Okay, and again, for those who go to pre-calc, we'll do more of this next year, but yeah, 270 degrees is the same as 3 pi over 2. Okay? Now, we'll go a little quicker through these other ones because they're really the same idea. So I've got 150 degrees, and I want to convert that into radians. So what we do is put 150 over 1. Again, pi over 180 is always the conversion unit. Pi over 180. Okay. Now, again, I'm making these ones sort of similar. The next video will change it up a little bit. A 0 in 150, remember, and a 0 in 180. So those zeros can cross out. So I can cross out the 0 on 150, cross out the 0 on 180. So now what I have is 15 and 18. See that? Now I just have 15 and 18. What's the biggest thing that divides into 15 and 18? And again, use your calculator. You got to think through that. So what can divide into 15 and 18? The only thing that can divide into that is 3. I can divide 15 by 3 and 18 by 3. Okay? 15 divided by 3 is 5. So that could become 5 over 1. Okay, and then pi over 18 divided by 3. 18 divided by 3, that's a 6. Okay, and again, the last step, multiply across the top, 5 and pi on the top. 1 times 6, 6. Boom. There's our answer. 5 pi over 6. 5 pi over 6. Okay. Last one, and then I'll give you a couple of these to do on your own. 480 times pi over 180. Okay, now again, the zeros cross out. Now we're trying to say what's the biggest thing that can go into 48 and 18. So the biggest thing that goes into 48 and 18, again, this is going to be a challenge. You might need to actually reduce more than once. Let me go ahead and let's do one that we maybe would reduce more than once. So I have 48. I got 18. Okay, I'm trying to think, okay, what goes into that? Okay, I know that 3 goes in. So let's reduce by 3. Okay? So 48, again, you might need to grab your calculator. Now, I'm a trained professional, so I can do this in my head, but you probably need a calculator. 48 divided by 3 is 16. So I got 16 over 1 times pi over, okay, 18 divided by 3. Okay, we just did that up here. 18 divided by 3 is 6. Now, here's the problem. I'm not done because, look, 16 and 6 can still be reduced by something that they have in common. What can divide into 16 and 6? A 2. They can both be divided by a 2. So, guys, so 3 was not the biggest number that could have got. Something bigger could have gone in. Actually, 6. 6 could have gone in there. But we didn't notice that, or when you're doing this on your own, you don't see that's happening. So, guys, if you divide and there's still something that can divide, you got to keep going. So now 16 divided by 2 is 8 over 1. And then pi over 6 divided by 2 is 3. And then, guys, here's my answer. Let's go down here. 8 times pi, again, multiply across the top and the bottom. So 8 pi over 3, boom. There's our answer, 8 pi over 3. So again, I wanted to show this where if you reduce by something and it's not all the way done, you can still divide, reduce it again. That's okay. Now, 8 and 3 cannot be reduced. Nothing goes into 8 and 3, so it's done. So 8 times pi, 1 times 3, 8 pi over 3, there's my answer. Okay, so again, just do the best you can on these. Okay, the homework problems are down here. Okay, again, just take them times pi over 180, reduce what you can as far as you can go down. Okay, and that's going to be our problem. Okay, we'll make this a little bit harder on the next video. Okay, thanks guys, take care, bye.